Hi guys, today's lesson is section 4 and it's on scientific notation. Now I'm hoping that you watched the video that talks about scientific notation in great detail. So now you're ready to just take the notes, copy the notes down and listen to my explanation. And hopefully I can clarify this for you a little bit more. Scientific notation is used to write either very big or very small numbers, and it is a product of a factor and a power of 10. And I don't know what this is, so you don't need this part. So now there is a requirement for the factor in the scientific notation. It's like a limitation. It has to be, so the factor in scientific notation has to be greater than or equal to 1, but less than 10. So a factor, a number, times 10 raised to a certain power, right? So that number has to be either greater than or equal to 1, but less than 10. So make sure when we write numbers in scientific notation, it satisfies this requirement. Now, we have two types of notation, standard notation and scientific notation. And today we're going to learn how to convert from one another, compare them, and then order numbers written in scientific notation from least to greatest. So the first thing we're going to do is we're going to take a look at converting scientific notation to standard notation. And as you can see, the big number 4,698,000 written in scientific notation is simply 4.698 times 10 to the 6th power. Notice 4.698 is greater than 1 but less than 10, and then our exponent is positive. So I just need you to understand that very big numbers or whole numbers will have a positive exponent, and very small numbers such as decimals will have a negative exponent, okay? So let's get started. Converting scientific notation to standard notation, you guys. The first example, 2.3 times 10 to the 4th power. So the first thing I'm going to do, I'm going to write down 2.3. Okay, and then I'm going to take a look at my exponent. My exponent is positive and it's 4. So what I'm going to do, I'm going to jump from my old decimal point to the right, because my exponent is positive, right? And all numbers are to the right of 0, positive. So I'm jumping to the right 4 times. So I'm going to jump 1, 2, 3, 4. And then I'm going to fill in those crevices with zeros. 1, 2, 3, like that. So that is my answer, and my answer is 23,000 when you convert 2.3 times 10 to the 4th to the standard notation from scientific. Let's take a look at the next example, 5.94 times 10 to the 7th power. And again, I'm going to take a look. I'm seeing 7. So I'm just going to rewrite 5.94. And I'm going to jump 7 times to the right from my old decimal to my new one. So let's take a look. 1, 2, 3, 4, 5, 6, 7. I'm going to fill them in with zeros and write down my answer, which is a really big number. And let's see, I'm going to put decimal, so it would be 59,400, 59,400,000, I'm sorry. Okay. Now, example number 3 has a negative exponent. So the same thing, I'm going to rewrite 1.3. Okay, now exponent is negative, and I know that negative numbers are to the left of 0, so I'm going to jump to the left 3 times. 1, 2, 3. Okay, and fill those in with zeros. Whoops. The zeros, not 6s. And I'm going to put 0 right here. So my final answer is 0.0013, right? And that is standard notation. Pause me and do this one. Okay, and 5.2 again, same thing, 5.2. I see 10 to the negative 5th power, so I'm going to jump 5 times to the left. 1, 2, 3, 4, 5. Put a decimal point. Fill those in with zeros. and my final answer will be 0.0000052. Okay. So again, positive exponents, you're going to move decimal to the right, and negative exponents, move decimal to the left when converting from scientific to standard. Moving on, let's take a look at converting standard to scientific. So right away, I'm going to write down my requirement, my limitation. And remember, your factor has to be, your factor A has to be greater than or equal to 1, but less than 10. Okay, and we are jumping, let's write this down, from new decimal point to old one. Okay, what is she talking about? Here we go. So ladies and gentlemen, I have a big number, 46,500,000. I need to write this in scientific notation. So what I need you to do is I need you to decide, where should I place my decimal point so it will satisfy my my requirement for my factor. So I have 4, 6, and 5. If I put it between 6 and 5, it would give me 46.5, which is greater than 10. But if I put it between 4 and 6, it will give me a decimal 4.65, which is perfectly where I want it to be. So what I'm going to do is I'm going to put my decimal right here. Okay. Now, my old decimal was right here at the end, right? So now I'm going to jump from new to old. How many times am I jumping? So again, I'm going to write down 4.65, right, times 10. And now I just need to figure out what my exponent is by counting the number of decimal places I'm jumping. So from new to old, 1, 2, 3, 4, 5, 6, and 7. So that's going to be raised to the 7th power, right? We're jumping this way. Okay. Now, please remember, whole numbers should give you a positive exponent, and decimals should give you negative exponent from the previous set of notes. So 932 is a whole number, so I know my exponent will be positive. So I'm going to put my decimal between 9 and 3. And I'm going to jump 1 and twice to the right. So it's going to be 9.32 times 10 raised to the 2nd power. Now example number 7, I have a decimal. So right away, I know I'm going to have a negative exponent. Remember, we're jumping from new to old. So I'm going to put my decimal between 6 and 4. And I'm going to jump to the left. That's why we have it negative. So 6.4 times 10. And let's jump 1, 2, 3, 4, 5 to the old, new to old. So that would be 6.4 times 10 to the negative 5th power. And of course, example number 8, try this one on your own. I'm going to put my decimal between 1 and 1 right here. So it will give me 1.19 times 10. And now I just have to go negative what? 1, 2, and 3 times. So negative 3rd power. That was easy, right? Not too bad. Scientific notation is fun. Now let's take a look at how do we compare scientific notations. Ladies and gentlemen, you compare the exponents of a base 10, right? So base 10, we're going to compare the exponents, but what do I do if the exponents are the same? Well, you simply compare the factors then. So if the exponents are the same, then you compare its factors. So in example number 9, we have 7. And then we have 6. Well, I know for sure 6 is less than 7, right? So therefore, 1.372 times 10 to the 7th is greater than the other one. Now, example number 10, my exponents are the same. That means now I have to take a look at the factors. So 4.7 is smaller than 7.9. So therefore, I'm just going to put this. This 4.7 times 10 to the 3rd is smaller than 7.9 times 10 to the 3rd. And finally, our last part here, ordering scientific notations. Again, we're going to follow the same rules. We're going to compare the exponents and order them from least to greatest in order of exponents. And if exponents are the same, then we're going to take a look at the factors. So 4 and 4 are the same in the example number 11. So I'm going to take a look at 5.1 and 4.9. And 4.9 is smallest. So this is this smallest scientific notation. Then the next one would be 5.1 times 10 to the 4th power. And finally, the biggest one is 1.2 times 10 to the 5th power. Last example, I do see in example number 12, 2 scientific notations and then 2 standard notations. So before you can order anything, how about we write those standard notations as scientific? So let's quickly do that. I'm going to put my decimal between 9 and 5. So it's going to be 9.562301 times 10. And that's going to be 1, 2, 3, 4, 5, 6 to the 6th power. And the last one, I'm going to put between 9 and 0. So that's going to be 9.05 times 10. And that's going to be 1, 2, 3, 4, and 5. Now I'm going to order them from least to greatest. Please use original numbers to list your answer. So -6 is the smallest exponent. So this is going to be our smallest one, 9.05 times 10 to the -6. The next one I have, let's see, 5th power. So I'm going to write this as 905,000. The next one, I see 2 6 exponents that are 6, so they're the same. I'm going to compare the factors. 9.5 is smaller than the other one, so that's going to come next. 9.5 times 10 to the 6. And finally, I'm going to rewrite our largest number using original number, 9,562,301. That would be our final largest number. And that's how you order scientific notation. Email me if you have any questions, and I will see you in the next lesson. Thank you.